the data have to be stored as bits of one or more storage devices. Whatever the data that we have in a database management system should be stored. Then only we can view that data and we can access those data. So here you can say that we have a different storage devices in order to store the data. Is it of three types? One is primary storage, secondary storage, and we have a tertiary storage. These are the storage device hierarchy that we can see, or we can be used any one of these data storage media in order to store the content of database. Hello everybody, warm welcome to one and all. Welcome back to the session 5 of Unit 4 as the B.C.A's 4th semester subject called Database Management System. As we all know that in short it is Dbms. So in this chapter we will be learning regarding this storage strategies. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of my previous session. As we all know that in the last session of this unit, we have discussed regarding deadlocks in concurrent transaction, and also I have discussed regarding what do you mean by deadlock, why it will going to appear and how it will going to act in a concurrent transaction, that I discussed in my last session. Along with that, we had discussed regarding the failures. In that we got to know regarding the types of failures or a classification of failures and what are the methods or what are the techniques that we have in order to recover from that failures. That is what database recovery technique, that is also I have discussed in my last session. So in our today's session, we're going to look about this introduction to the storage strategies. Along with that, we'll see what are the storage device hierarchy we have, on what basis we are going to have that measurements, or on what basis we are going to make that hierarchy, that I will be discussing along with a RAID or RAID. So we'll get into the today's session, that is regarding this storage strategies. So why storage is required in a computer's memory, or why we need to store the database data items or whatever we have in a database that should be saved, right? So if you consider the database system or a DBMS system, that will going to provide an excellent way of representing or having a high level view of data, right? So that is not only limited to see the data. Once it got processed or whatever the processing has been done, that needs to be stored in a computer's memory. Then what are the strategies we have, or how it will going to be classified, on what basis we are going to store the data, that and all we are going to learn here. So here the data have to be stored as bits of one or more storage devices. Whatever the data that we have in a database management system should be stored. Then only we can view that data and we can access those data. For that purpose, we are dividing that storage strategy into the three types. So before that, we'll see here, for storing the data, we have a different types of storage options in order to store any kind of data or whatever the data that we have in a database. So for that, we are going to have a different kinds of storage option that will going to be based on the speed as well as accessibility. As per the speed and accessibility, we are going to classify it. So here you can say that we have a different storage devices in order to store the data. Is it of three types? One is primary storage, secondary storage, and we have a tertiary storage. So these are the three types. So in the next slide, what we have, that is regarding, we are going to divide, or we are classifying the storage media, or we are classifying the storage devices on the basis of cost as well as the medium, or how it will going to be communicated. Along with that, we are going to think about its reliability. If something goes wrong, how potential it is in order to overcome from that situation or from the failures. So based on all the scenario, like how it will going to be accessed, what is its cost per unit, or how it will going to be stored, what is its size, based on all the parameter, we will be classifying that storage media. So amongst that, first we have a cache memory here. As the name indicates, cache in the sense what? It is the fastest memory, but it will going to store only less amount of data which is required for the immediate processing by the computer system or by the CPU. That data will going to be stored in a cache memory. So the cache is the fastest and most costly form of storage. So here it will be costlier when we compare it with another storage devices. Why? Because it's relatively small. The size will be very small, but it will going to store a data which is immediately required for the processing. So its use is managed by the computer system hardware. So why we are going to use it? In order to manage the computer system hardware and its functionality, we are going to have this cache. Second, what we have here, main memory. So as we all know that main memory is also known as a primary memory of a computer system. So the storage medium used for data that are available to be operated on in main memory. Whatever the data and information that we have in a database which needs to be operated immediately, or as we all know that whatever could be the data or information, if I wanted to execute in a computer CPU or in the central processing unit, then it has to be in the main memory. Then only the processing will going to takes place. So that kind of data will going to be stored in this main memory. And also the general purpose machine instruction, all the machine instruction will going to operate on this main memory. All that kind of information which is immediately required or which needs to be operated immediately, that will be in the main memory. That is what? Primary memory. But it is volatile in nature. So if power off goes off, or if power goes off, at that time whatever the data that we have in a main memory will going to be get vanished. So next we have a flash memory. This is just like what? A pen drive. So why we are going to use this flash memory? So somehow this is differ from the main memory. Why? Because in the flash memory, whatever we have, the data will going to be stored even if the power fail occurs or any failures which is related to the power consumption and all. If something goes wrong with it, then the data will be safe in the flash memory, but that is not in the case of this main memory. And also we have two types of flash memory. One is NAND and another one is NOR flash. Then what is the use of having this flash memory and how we are going to use it? So this will be used for storing the data in USB keys. So as we all know that we are going to plug USB cable or a key here that can be plugged into the USB slots of the computing devices. So it's just like flash memory is nothing but it's what? Pen drive itself. So there also we can store the data. So that will be based on the size of that pen drive or a flash drive memory here. We'll see the next type of storage strategy here, that is magnetic disk storage. Whatever the data or a long-term online storage of data is going to take place under this magnetic disk. So entire database, usually entire database and its schema, metadata, catalogs and all the log tables, everything, entire database will going to be stored in this magnetic disk. But if you wanted to execute the content of the database or a DBMS, that should be copied to the main memory. Then only we can execute it. Why? Because whatever we wanted to execute, that should be in the main memory. That is what the reason here. So the system must move the data from disk to main memory so that can be accessed. If you wanted to access the data, it has to be in the main memory. Anyway, this database content, everything will be in the magnetic disk storage. But if I wanted to execute its content, should be copied from this magnetic disk to main memory. Then only we can access that data. So when it comes to the main memory, processing will going to take place. If everything is done, after that whatever the content that has been written should be go back to the magnetic disk storage again. So you can see here, after the system has performed the designated operation, whether it is what? Selection, insertion, deletion, whatever could be the operation which has been done to this database. Once it is done, the data have been modified, must be written to the disk. Again it has to be copied to the disk only. This is what? Magnetic disk storage. So next we have optical storage. If I say optical storage, then CD and DVD should comes to your mind. So with the help of this optical storage, that is what you can see the compact disc or a CD, which can hold about 700 megabytes. So up to 700 megabytes of data and has a play time of about 80 minutes. That is what we are specifying the configuration of a CD. CD can also be used in order to store the data of a database, and also we have a DVD or a digital video disc which can hold 4.7 or 8.5 gigabytes of data per side. So if you consider a DVD, it has two sides, right? At one side it has the ability to store 4.7 or 8.5 GB of data. So it can be take up to 17 GB by two-sided disc. This is how, or this is one of the media or one of the methodology in order to store the content of a database. Fine. So these are the storage strategies we have. Along with that, we have a tape storage. So tape storage, as the name indicate here, the data will going to be stored in a sequential form. How it will work? We can see here, it is used primarily for the backup and archival data. So wherever we have archival data and this backing up of the existing data, there we are going to use this tape storage. So already this if you see the advantages or benefits of database, there is a backup of a data. So that backup data will going to be stored in this tape storage. So the magnetic tape is cheaper than the disk. So why this magnetic tape is considered as cheaper than the disk? Because its access to the data is much lower. So if you have one advantage, then there will be one more disadvantage also. So the accessibility of a content, whatever we have in a magnetic tape or in the tape storage, is lower. That's why it is considered as what? Cheaper in cost. Why? Because tape must be accessed sequentially. So it will be in this format. So whatever the data we have, that needs to be accessed one by one. Should be in a sequential form. It can't be accessed randomly. That's why it is cheaper and least recently used, and it can be slower for the execution. And also the tape storage is referred as a sequential access storage. Why? Because we are going to access it one by one. The content will be accessed by in a sequential form or in a linear form. That's why it is considered as what? Sequential access storage. And what we are going to call disk storage, magnetic disk we have, right? So what we are going to call that as? That is direct access storage. Why? Because if I wanted to access any of the content from any location from that disk, that can be happened with this disk storage, but that is not possible with the tape storage. And also it is possible to read the data from any location on the disk. There is no rule or a boundary in order to access the data from the disk, but there will be a sequential accessing methodology in this tape storage. And also these tapes have a high capability, that is what 40 to 300 GB of tapes are currently used or available. So in order to store that much of data, you can go with this tape storage format, and we can remove it from the tape drive. So it is flexible in nature. If you don't want it, you can remove it. So they are well suited for the cheap archival storage. Whenever you wanted to have a less archival storage, or whenever you wanted to have a less backup storage space, at the time, instead of paying much for other data storage types, you can go with this tape storage. Fine. This is regarding storage strategies. And next, here we can see that we have some storage device hierarchy. On what basis we are going to consider a cache memory will be in the top and this tape storage in the top or bottom. So on what basis we are going to do it? The various storage media can be organized in hierarchical form according to their speed and their cost. Whether it is costlier or cheaper, it will going to provide more, it has a less response time, it has more response time, and what is its speed of processing or accessing the content from the disk or a main memory. So by calculating all these things, we are going to have a hierarchy, right? So in this, higher levels are expensive. Whatever the data storage device that we have at the top, that will be more expensive, but they are fast. So whichever we have at last, then it is cheaper, but it will be slower in accessing a data. So as we move down to the hierarchy, the cost per bit will going to be decreases. The amount will be decreases from the top level to bottom level, but its accessibility will going to be less or slow, but access time will going to be increases. If the access time increases, as well as the payment or a cost per that unit will be decreases, or it will be cheaper than other type of the devices which is present at topmost places. Here you can see that we have a cache memory here. It will be costlier and it has a fast access. Accessibility will be fast. And main memory, we have a flash memory, magnetic disk, optical disk. So at last we have a magnetic tapes. As we can recognize here, magnetic tape will going to be cheaper in cost, but the accessing time will be very much. So it will be least recently used or least likely to be used. So these are the storage device hierarchy that we can see, or we can be used any one of these data storage media in order to store the content of database. We'll see the next topic, that is regarding RAID. At the end of this session, you will be knowing what this RAID is all about. So here you can see that the data storage requirements of some applications. So for example, if I consider the web or a database and multimedia application have been growing very fast, right? So why? Because the data is also going to be very much in the database or in a multimedia application. If you consider the Instagram, WhatsApp, by day the number of users are increasing there. So if the number of users are increasing, their data is also going to be increased or will be growing so fast, so that it will require a large number of disks in order to store the data or in order to store the content of that web or database or any of the multimedia application, so that the disk drive capabilities is also growing very fast. So in order to satisfy the storage area or to store the data of any of the application, the disk area or a disk drive capability is also growing very fast. But here we have a large number of disks in a system present opportunities for improving the rate at which data can be read or written if the disks are operated in a parallel. You just imagine if we have 10 disks in a system. So if all are operating in a parallel, then the reading and writing operation will going to be very fast. So it needs to be parallel. So read or write option, whatever we have in a disk, should be parallel. So if it is working simply, if another disk are idle, then it's of no use. So in order to make it more worthy, then all the disk or whatever the disk that we have in a computer system should work parallelly, or it has to read the data or write the data should be in parallel manner. So here several independent reads or writes can also be performed in parallel. For example, if you don't want it to do it together or in a parallel manner, independently or separately, we can have this read or write operation. That is also going to be parallel. Fine. So here this setup offers the potential for improving the reliability of data storage. Why? Because if there is no confusions between the reading or writing, if it is not merging with another operation, at that time it will increases the reliability of a data storage, because redundant information can be stored on multiple disks. So why? Because if something goes wrong with one disk, I have a same content in another disk. That is what the reason reliability is going to be more in this data storage type. Along with that, failure of one disk does not lead to the loss of data. Why? Because if you consider this disk, so in this disk, it will going to have a same data, even in another disk also going to have a same data. If something goes wrong with this disk, so from this disk, we can retrieve the data back, or we can get the backup of the failure data. That is what the reason it will going to improve the reliability of data storage. And we have some variety of disk organization technique. This is not going to be same, or we are going to use a static methodology. We have a different strategies, or we have a different mechanism of disk organization technique. So together we are calling that as a RAID, or a redundant arrays of independent disk. In short, it is RAID, redundant array of independent disks. So that have been proposed to achieve the improved performance and reliability. So if you have more strategies, or if you have a different way of representing or having the disk organization technique, then it will going to be helpful in order to access the data as soon as possible from the disk. So reading and writing operation, if it is taking place parallelly, if it is more faster in the response, so at the time the reliability is also going to be increased. So in order to have a different technique, we are going to use a collective technique called RAID, or it will be considered as what? Redundant arrays of independent disks. It will going to give a different technique for the disk organization. With the help of this, we can improve the performance and reliability of a data storage. For that reason, we have this RAID. I hope you all understood. It's all about our today's session. In my coming session, we're going to see about the indexing, hashing, as well as this file organization. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.